Rayon and nylon cords are now common. Cords of synthetic fabric have high tensile strength. They resist stretching, but are flexible under load. The cords are placed parallel to each other and impregnated with rubber to form sheets called plies. Plies have high strength in one direction and are flexible in other directions. When cotton was used as a cord, the number of plies or layers in a tire was a measure of the tire's strength. Newer cord materials use fewer plies. A modern steel-belted radio with a 6-ply rating may have just 2 plies in its sidewall. Having fewer plies makes the tire more flexible. Higher numbers of plies make a tire's response to bumps harsher. The bead of the tire is made of a cord of high tensile steel coated with rubber. The end of the ply is wrapped around the bead, which is then wrapped in rubber to stop chafing of the plies and also to seal the bead against the rim. The length of the wire used for the bead determines the rim diameter of the tire. Belts that reinforce the tread area of the tire are mostly made of braided high tensile steel wire, but they can also be made of rayon or polyester. The inner liner of a tubeless tire is made of soft rubber. The inner liner must be flexible and airtight. Radial ply tires have much more flexible sidewalls due to their construction. They use 2 or more layers of casing plies with the cord loops running radially from bead to bead. The sidewalls are more flexible because the casing cords do not cross over each other. However, a belt of 2 or more bracing layers must be placed under the tread. The cords of the bracing layers may be of fabric or of steel and are placed at 12 to 15 degrees to the circumference line. This forms triangles where the belt cords cross over the radial cords. The stiff bracing layer links the cord loops together to give fore and aft stability when accelerating or braking, and it prevents any movement of the cords during cornering. The cord plies flex and deform only in the area above the road contact patch. There are no heavy plies to distort, and flexing of the thin casing generates little heat, which is easily dispersed. A radial ply tire runs cooler than a comparable cross-ply tire, and this increases tread life. Also, a radial tire has less rolling resistance as it moves over the road surface. Control of a vehicle in any weather conditions depends finally on frictional forces generated between the tires and road surface. On a dry road, a smooth rubber surface can provide a high coefficient of friction, sufficient to maintain a degree of control during braking, accelerating, and cornering. In wet conditions, the coefficient of friction between a smooth tire and the road surface falls to an extremely low value. Grooves in the tread pattern clear water away from the contact patch area. This allows a relatively dry area to be formed and for road adhesion to be maintained. Tire tread patterns can be classified with these general characteristics. Directional tread patterns are designed to provide a range of attributes during particular driving conditions. The tire can only be mounted to the wheel so that it revolves in a particular direction to correspond with the tread pattern. An arrow on the tire sidewall indicates the designed direction of forward travel. Non-directional tread patterns are designed in such a way that the tire can be mounted on the road wheel for any direction of rotation. Symmetric tread patterns have the same tread pattern on both sides of the tire and are usually non-directional tires. Asymmetric tread patterns have a tread pattern that is different from one side of the tire to the other. They are designed to provide good grip when traveling straight and in turns. They are generally directional tires and must be fitted to the road wheel in accordance with the fitting instructions to ensure that they perform as designed under operating conditions. Information on tire aspect ratio is now included in the sidewall marking, together with the type of construction and the speed rating. The speed rating of the tire is given by the letter code, which indicates maximum recommended speed for that tire. Common symbols for passenger car tires include S for up to 110 miles per hour or 180 kilometers per hour, H, up to 130 miles per hour or 210 kilometers per hour. V, up to 150 miles per hour or 240 kilometers per hour. And Z for over 150 miles per hour or 240 kilometers per hour. Radial-ply tires have always been marked with the section width in millimeters, but with the rim diameter in inches. For example, 185 is section width in millimeters. 70 indicates a 70% aspect ratio. H is the speed rating for up to 130 miles per hour or 210 kilometers per hour. R indicates radial-ply construction. 13 indicates the tire is suitable for fitting to a 13-inch diameter rim. Totally metric types are also manufactured. For example, 190 is the section width in millimeters. The aspect ratio is 65%. The speed rating is H for up to 130 miles per hour or 210 kilometers per hour. R indicates radial-ply construction. 390 indicates the tire is suitable for fitting to a 390 millimeter diameter rim. Metric diameter rims cannot be fitted with inch diameter tires, nor vice versa. Although tire markings may remain traditional, say 255/45 ZR17, there is a worldwide move towards an ISO metric standard which uses letters. P for passenger, LT for light truck, C for commercial, and T means temporary use as a spare wheel. The tire may have a load index number indicating the maximum load a tire can carry at the speed indicated by its speed symbol, which follows the number. So a P-series metric size code may read in full P205/65 R1592H. P for passenger car tire. 205 is the section width in millimeters, with 65% aspect ratio. R, radial-ply construction. 15-inch diameter rim. 92 load index for a maximum load of 630 kilograms. And H for a speed rating of up to 130 miles per hour or 210 kilometers per hour. Further development of high-speed tires has expanded the speed categories to include W and Y. In another example, Z indicates a speed over 150 miles per hour or 240 kilometers per hour, but the load and speed rating is taken as the maximum load and speed. That is 89 for a maximum load of 580 kilograms, and W for 165 miles per hour or 270 kilometers per hour.
Nope. Just kidding. Like it.
That's so cheesy.
Like it.
The Continental Corporation is one of the world's leading suppliers to the automotive industry. It has extensive know-how in tyre and brake technology, vehicle dynamics control, electronics and sensor systems. The aim is to make individual mobility safer and more comfortable. The corporation comprises the Continental Automotive Systems, ContiTech and Tyre divisions. Among tyre manufacturers, Continental is the #1 in Germany, #2 in Europe and market leader for winter tyres. Every year, some 100 million tyres made by the Continental Corporation come onto the road. Every fourth new car runs on Continental tyres. The tyre is a complex high-tech product with more than 10 different rubber compounds and 15 to 20 components. The process chain follows the production flow from the compounding to the last station for quality control. The tyre consists of a combination of textile cords, steel wire, rubber compounds. These basis elements are incorporated into the components of the tyre in a specific way. The building phase is split into two parts. The liner, ply, beads and sidewalls are assembled as the carcass. The belts, cap plies and tread as the belt assembly. Carcass and belt assembly are placed together to form the green tyre, and this is vulcanized at a high temperature to form the finished tyre. The final inspection involves both visual and sensory checks. The ingredients for the compound are mixed, extruded, rolled, cut and collected together for further processing. Before the finished compound sheet, stamped with a manufacturing code, leaves the mixing department, a multi-phase mixing procedure has been completed. The compound consists of fillers such as carbon